In this video, we're going to try to solve a sample problem. So this is about logical rules of inference. Say, prove the validity of the following argument. Either Juan isn't stupid and he is lazy, or he is stupid. Juan is stupid, therefore Juan isn't lazy. So first thing that we have to do is to come up with logical propositions. So you have either Juan isn't stupid, so let's come up with a variable, say S. So for Juan is stupid, for example. So Juan is stupid. And lazy, so say L. So let's just grab this one. It's lazy. So either the statement is either Juan isn't stupid and he is lazy, or he is stupid. So that is an OR statement. So this is an OR statement, and stupid is S, and we have an AND. So not stupid and lazy. So the second premise will be Juan is stupid, so S, therefore not lazy. So we came up with the logical expression not of S and L, or S. Second premise is S, therefore not L. So we could come up with a simplification for this. First premise can be simplified by logical equivalences, or say distributive property. Say first thing that we are going to do is to commute. Say commutative. Wait. So commutative with distributive. So applying the commutativity and distributive property, we're going to have, so to premise 1, and this is premise 2. So for premise 1, we have S or not of S. And S or L. So this one will simplify to truth by negation, and afterwards, let's first take note of this. So this is true or and S or L. So after that, commutative and identity. So we have S, so this will be equivalent now to, again this is separate, so we have now simplified into S or L. So P1 we have S or L, and for S, so therefore not of L. So the way to analyze this is, if you have an OR statement, if you have a disjunction, so the disjunction is giving us S or L. We know that S will be true, so this is true for the AND to be satisfied. Then the first premise, premise 1, should be true as well. So we already know that this statement, this S, is already true. So does it imply that not of L should also be true? And the answer is, it doesn't follow. So this is a fallacy. And the explanation basically is, if you have truth here, L can either be true or it could be false. So therefore it's either L or not L. So that's basically the explanation, because the first statement is already true and this is a disjunction. So this disjunction will be automatically true if one statement is already true. Doesn't matter if the second statement is true or false. So it's not an implication that it should be not of L. We can also verify this with a simple truth table. So if we could come up with the columns for these values, say I have S and I have L, say false, true, true, false, and true, true, for example. So if S or L, you will have false, true, true, and true. And so if we AND this with the S, so we will try now, does it imply not of L? So if we AND it with S, so false and false, so that will be false. So true and false, that will be false. So if this is AND true and true, so this will be true, and true and true, so this will be true. Does it imply not of L? So false, does it imply false implying not of L, so not of false, so false implying truth, this will be true. False implying false, this will be true. So true implying not of false, so that will be true. So false, true implying true, this will be true. Almost a tautology. But the final column will be, or the final row is true implying not of true. True implying false will be false. And this is the highlight of it not being a tautology. So this, again, by logical equivalence and truth table, we can see that it's a fallacy. It's not valid. So that's it.